guys. Hi, so we are moving on with chapter 10. We learned last lesson about inscribed and circumscribed polygons. Remember, if one is inside of the other with the vertices all in, all the vertices inscribed, it's called inscribed. The one on the outside is called circumscribed about. So for example, the circle's inscribed in the polygon, but the polygon is circumscribed about the circle. So let's look at this problem. Let's go ahead and label what we have. It says that we have a trapezoid is circumscribed about the circle O. This should be circle O, so let's label that. It says angle X and angle Y are right angles. That's not so important to us, I'll tell you that much. And now you want to label mine exactly how, you want to label yours exactly how I'm labeling mine. So XW is 16. Y to Z is 7, and that's it. So this sort of looks like a walk-around problem from 10.4. The only issue is that usually for a walk-around, we have 3 out of the 4 sides. We don't just have 2. So this is actually a shortcut to the walk-around, and I'm not asking to find just one side. I'm asking to find the whole perimeter. Let's see how this shortcut's going to work. So we know because of the 2 tangent theorem, let's call these missing points. Let's call this A, B, C, and D. Okay? We know because of the 2 tangent theorem that XD and XA are congruent. We know that AW and BW are congruent. We know that ZB and ZC are congruent. And we know that CY and dy are congruent. Okay, now let's look at this. We know, now I know before we'd say like, okay, well, x to y is 16. If x to a is x, then a to w would be 16 minus x. But that's how we would do a traditional walk around. This is going to be a little bit different. Let's say that x to a is a lowercase a. That's the length. And a to w is a lowercase b. That's the length. It's an unknown length, and that's what we're going to use. Now, we know x to a and x to d are the same, so that means x to d is a lowercase a. And we know that a to b is the same as w to b, so that means that has to be a lowercase b. Now, let's keep going. Let's say that C to Z is P, and C to Y is M. Well, we know C to P is the same as Z to B, so that's a P, and we know C to Y is the same as Y to D, so that's an M. All right, where am I going with all this? Well, let's look. Let's take one segment that has a length. So we know X to W is 16. Right? We know XW equals 16. Well, what is XW made up of? Well, that's segment A length plus segment B length has to equal 16. What else do we know? We know that YZ has to equal 7. So what does that mean to us? It means that length M plus length P has to equal 7. Well, now let's look at the whole perimeter. Now, the whole perimeter and its little parts is A plus A plus B plus B plus P plus P plus M plus M. That's the whole perimeter. Now, guess what I'm going to do? I'm going to rearrange addition since addition's commutative, and I'm going to put every A and every B together, and I'm going to put every M and every P together. So I'm going to have A plus B, and then another A plus B. Then I'm going to have plus P plus M, and then another P plus M. Now, why do you think I did that? I did that because A plus B has to equal 16. So every time I have an A and a B added together, I could substitute in 16, and then another 16. And every time I see a P and an M added together, I know that's equivalent to 7. So that's going to be P plus M, so plus 7, and then another P plus M, another 7. So my whole perimeter is going to equal 16 plus 16 plus 7 plus 7. Let's go ahead and add that. So we have 16 plus 16 is 32, and then 7 plus 7 is 14. So our total perimeter is 46. And that's our answer, perimeter. I shouldn't say P because P represents a side length. So I will write perimeter. 46 units long. Okay. So let's erase this and get into some more difficult problems here. So the radius of a circle is 8. The radius of a circle is 8. Find the perimeter of the equilateral triangle. Okay, so what's going on over here? We know that a radius starts at the center and it goes to the rim of the circle. So it starts at the center and it goes to the rim. Now, there's so many places we could draw a radius, right? We could draw a radius like that. We could draw a radius like that. Those places are not going to help us. So where are we going to draw the radius so it actually helps us? Well, we are going to draw the radius so it actually goes to the points of contact where our vertices lie on the circle. Let me use my segment tool here. And then one more. So we have all those radii drawn in, and we know they each have a length of 8. I'm just going to label 2 of them. So I'll say this is 8 and this is 8. We know all of them have a length of 8. We want to find the perimeter of the equilateral triangle. Okay, what do I want you to do? So there's so many different ways we can go about this. But I guess the way I'm going to have you go about it, I'm actually going to erase these 8s for a minute, is by us drawing in the radius. I hope that you recognize that we've created central angles here. Central angle, central angle, central angle, right? Now, what do we know? I know we have 3 central angles. I also know that if the chords are congruent, right, then the arcs are congruent, then the central angles are congruent. Okay, so if the chords are congruent, the central angles are congruent, the arcs are congruent. So if all of these central angles are congruent, how am I going to find what just one of those central angles are going to be? Well, all of these central angles together make that whole entire circle. So I'm going to say, well, this is 360 divided by 3, which means each central angle is going to be 120 degrees. So that means each of these central angles will be 120 degrees. So let's go from there. So 120, 120, 120. Now what I'm going to do is I'm going to pick, I hope you realize we have 3 little mini triangles. I'm going to pick one of the mini triangles. So I'll choose this one right here. And what I'm going to do is I'm going to draw part of a radius that's perpendicular to that chord. And if you remember, if part of a radius is perpendicular to the chord, that it also bisects that chord. So we're going to have 2 right angles here, which means that these triangles are actually congruent. So that 120 is going to get split into 2 60s. And now I'm going to fill black in that the radii were 8, right? So I'm taking one of these triangles. And what do I know I have? I know I have a 30, 60, 90 triangle. The hypotenuse is 8. So we know opposite the 30 is x. We know opposite the 60 is x root 3, and opposite the 90 is 2x. So what do we have? We have 2x is equal to 8, so x is equal to 4. All right, this is great. So I want this side of the triangle because we're trying to find the perimeter. So that's going to be x root 3, which means it is 4 root 3. So if this is 4 root 3, then this is 4 root 3. Then the whole side of the triangle is 8 root 3, which means this is 8 root 3 because it's an equilateral, and this is 8 root 3, which means it's equilateral. So the perimeter is going to be 8 root 3 plus 8 root 3 plus 8 root 3, which is 24 root 3 units long. All right, next one. It says the diagonal of a square equals 4. Find the radius of the circle. Okay, so first thing I'm going to do is I'm going to draw in a diagonal. And right now, I'm only going to draw in I'll actually draw in both diagonals. Now we know in a square, all the sides are congruent. We also know that the diagonals, all the sides are congruent, that the diagonals are congruent, and the diagonals bisect each other. So if one diagonal is 4, each part of them has to be 2. Okay, what else do we know? We know in a square, the diagonals are perpendicular to each other. Now, what is it that we want to find? Do we want to find a radius of a circle? Well, like I said, we know that this segment right here that I highlighted in yellow is a radius, but there's no way on earth I'm going to be able to find out that length right from that. So where do I want to draw a radius that will actually help us? I'm going to go and I'm going to draw a radius straight down. And what happens when a radius touches a tangent? What do we get? We get right angles. So now I'm going to pull apart one of these triangles. Now, well, before I pull apart one of these triangles, we know that these two triangles are congruent. So what does that mean? These are 45, 45, 90 triangles. I'm going to take one of these triangles. I'll take this one right here. And I'm going to redraw it. So I know the hypotenuse is 2. I know I have a 45, 45, 90. I know opposite the 45s are x. I know opposite the 90 is x root 2. So my equation is x root 2 is equal to 2. Divide by root 2 on both sides. Multiply by root 2 to rationalize. So we're going to have x is equal to 2 root 2 over 2, which is x is just equal to root 2. So what does that mean for us? That means the radius is right here, root 2. The radius equals root 2. There we go. All right, 2 more problems. All right, so here it says a radius of a circle is 6. Find the perimeter of the regular hexagon. Remember, what does it mean to be regular? Regular means equilateral and equiangular. And remember, just because a polygon is equilateral does not necessarily mean it's equiangular, and vice versa. Just because a polygon is equiangular does not necessarily mean it's equilateral. For example, a rectangle is equiangular, but it is not equilateral. Example, a rhombus is equilateral, but it is not equiangular. But then you have something like a square. A square is considered regular because it's equilateral, all the sides are congruent, and it's equiangular, all the angles are 90, right? So just because you're equilateral does not necessarily mean you're equiangular and vice versa. But a regular polygon has to be equilateral and equiangular. So it's telling us the radius of the circle is equal to 6, and we want to find the perimeter. Now remember, we've done a problem like this already. I can draw the radius like that, but that's not going to be helpful to us. Where should we draw the radii to help us out? We want to draw the radii right to the corners where our polygon touches our circle. And by doing that, I'm making a whole bunch of little triangles. And remember, because the polygon is regular, all these chords are congruent. And if all the chords are congruent, then all of the central angles are congruent. And if all the central angles are congruent and I want to find just one central angle, what am I going to do? I'm going to take the whole circle, which is 360 degrees, and divide it by however many angles I have. 1, 2, 3, 4, 5, 6. I have 6 angles, which means each angle has to be 60 degrees. So we have 60, 60, 60, 60, 60. I'm going to leave one of them blank. Okay, so we're saying the radius of the circle is 6. So we know, forgot to label this, all of these segments that we drew in to create our triangles are all 6. Find the perimeter. So I need to find the side length of this polygon. So what am I going to do? I'm going to choose a triangle. And what I'm going to do is I'm going to draw part of a radius to the chord. And remember, I'm going to draw that radius perpendicular, or the part of that radius perpendicular. And if it's perpendicular, then it also bisects. So that means these triangles are congruent. So that top 60-degree angle is getting split into 2 30s. I'm going to pull apart one of these triangles. And I have a 30, 60, 90 triangle. The hypotenuse is 6. We know opposite the 30 is x, opposite the 60 is x root 3, and opposite the 90 is 2x. So we're going to set up an equation. 2x is equal to 6, so x is equal to 3. So that means this base is 3, which means this base is 3, which means the total side length is 6. Now, because all the sides are congruent, the perimeter is going to be 6 times 6, which is 36. All right, guys, last problem for today. So this time I have the polygon inscribed in the circle, or the circle circumscribed about the polygon. So let's see what we have here. So here we're being told that arc HG is 120 degrees. And now, go back a second. It says EFGH is a parallelogram. Because it's a parallelogram inscribed in a circle, think back to the last lesson. Parallelogram inscribed in a circle. What must it be? It has to be a rectangle. Okay, so now we know HGFE is a rectangle. I know arc HG is 120 and the radius of the circle is 6. Now remember, where do I want to draw these radii in? I want to draw them right to the points of contact between the polygon and the circle. So I'm drawing them in to make little triangles. Now, unfortunately, this is not a regular polygon. Because it's not regular, that means the chords are not congruent. So I cannot say that all of these central angles are congruent. I could say because this chord and this chord are congruent, that these central angles are congruent, and that these central angles are congruent. So this is going to take a little bit of work, okay? So now let's keep going. I know that a central angle and its arc are the same. So I know that this is 120, which means this is 120 degrees. I'm going to take, did they tell us anything? They told us the radii of the circle is 6. So 6, 6, 6. There you go. So I'm going to take one of the triangles, either the top one or the bottom one. I'm going to take this bottom one. And I'm going to follow the same procedure that we've been doing. So I'm going to take this triangle and I'm going to draw a perpendicular in it. And when I draw a perpendicular, it's going to make a right angle. I'm sorry, when I draw a perpendicular, not only are we going to make right angles, we're also going to bisect. And then these two triangles are congruent, which means the 120 is going to get split into 2 60s. So here we have a 30, 60, 90. The hypotenuse is 6. So opposite the 30 is x, opposite the 60 is x root 3, opposite the 90 is 2x. So we have 2x is equal to 6, so x is equal to 3. So this is 3 and this is 3, which means, oh, sorry, not 3. Sorry. Let's go back. X is equal to 3. That's the altitude. The base of this one would be 3 root 3. So this is a 3 root 3, which means this is a 3 root 3, which means e to f is 6 root 3. And in a rectangle, opposite sides are congruent, so h to g is 6 root 3. I cannot say that they're all congruent because they're not all congruent. In a rectangle, the top and bottom are congruent and the left and right are congruent. So now we're going to do the same thing for the side triangles. What do I mean by that? Well, right now, we know that these two angles make a straight angle, so they have to be supplement, which means this angle is 60 degrees. The supplement of 120 is 60. So I'm going to be working with this blue triangle that I'm highlighting right now. And once again, I'm going to draw in my perpendicular bisector. All right, so now that these two triangles are going to be congruent, that 60-degree angle is going to get split into two 30s. And now I'm going to redraw this triangle that we have. So we have a 30, 60, 90. I know the hypotenuse is 6. So we know opposite the 30, let's call this y. Opposite the 60 is y root 3. And opposite the 90 is 2y. So we have 2y is equal to 6, not x, 2y is equal to 6. So y is equal to 3. So then we know opposite the 30 will be 3, and opposite the 60 will be 3 root 3. So this time we're working opposite the 30. So this is 3 and this is 3, which gives us a total length of e to h is 6, which means g to f is also 6. Now we have everything we need to find the perimeter. So the perimeter is going to be 6 root 3 plus 6 root 3 plus 6 plus 6. So we're going to have 12 plus 12 root 3 or 12 root 3 plus 12. Doesn't really matter which way you write it. Addition is commutative. Okay, guys, so this was the end of our lesson today. And have a great weekend.